Imagine trying to write an entire encyclopedia using, like, a language that only has two words, just yes and no.
Yeah, that sounds completely impossible.
Right. But that is actually the reality running under the hood of every digital device around you,
Welcome to today's deep dive.
where our mission is to unpack the friction between human brains and machine logic.
Exactly. We're looking at a computer science guide, specifically Chapter 1 on number systems, to really decode the fundamental two-word language of computers.
Which is binary, of course.
Yeah, binary. And we are digging into why engineers had to invent this bizarre letter-filled shortcut called hexadecimal just to preserve their sanity.
So to understand that friction, we really have to strip the hardware down to its absolute core. Because computers, they don't natively understand letters or videos or even like the number 5.
They just see electricity, right?
Exactly. They operate strictly on electrical currents being on or O off F. And we represent those states as ones and zeros, which we call bits.
That's right. Yeah. And when you group 8 of those bits together into a standard 8-bit system, the underlying structure is actually remarkably elegant.
How so? Like, how does it work?
Well, reading from left to right, each column is assigned a descending power of 2. So you have 128, then 64, 32, 16, 8, 4, 2, and finally 1.
Oh, I see. So as a quick visualization for you listening, you can think of that 8-bit system as like a row of 8 light switches on your wall.
That is a great way to picture it.
Yeah, and each switch carries one of those specific point values. So to figure out the final number, you just add up the points for the switches flipped on and you entirely ignore the zeros.
Which works flawlessly for a microchip. A processor can read millions of those 8-switch configurations in a fraction of a second without breaking a sweat.
But that creates an interesting problem. If the machine reads those binary switches perfectly, why force a completely different letter-filled number system into the mix?
You mean when you look at code and suddenly it's not ones and zeros anymore?
Yeah, it's just this jumble of letters and numbers. Like, why abandon a system the computer already understands perfectly well?
Well, basically because human eyes aren't processors. Staring at thousands of lines of ones and zeros causes extreme visual fatigue.
Oh, I can imagine.
Yeah, and early programmers were constantly making transcription errors. So the solution they landed on was hexadecimal, or base 16.
Base 16, okay.
Right. Instead of our standard 10 digits, hex uses 0 through 9. And then it borrows the letters A through F to represent the values 10 through 15.
Wait, let me unpack this for a second. Does writing in hexadecimal actually change how the computer processes the data?
That is a really crucial distinction. And no, it doesn't change the underlying machine process at all.
So it's still just ones and zeros underneath?
Always. The hardware is still exclusively processing raw binary ones and zeros. Hex is purely a visual shorthand. It's a notation system engineered specifically for human clarity.
Ah, okay. So it doesn't actually compress the data size on the machine. It's just, a visual interpreter keeping us from going cross-eyed.
Precisely. Let's look at a 16-bit binary string, for example. 101 winner 1 winners free 11 winner 00001.
Wow, yeah, if you're a network engineer trying to type that out, you are definitely going to miss a zero.
Exactly. But if you map that exact same clunky string to hexadecimal, it condenses down perfectly into 4 neat characters, which is AF01.
AF01. Yeah, that is so much harder to mess up.
Right.
And I guess this explains why you see hex popping up in everyday tech all the time.
Oh, everywhere.
Like the next time you are setting up a Wi-Fi router and you look at the MEC address, or you're building a website and use an HTML color code like hashtag FF00000 for pure red.
Yeah, you aren't looking at some hyper-advanced alien math there.
You're just looking at a human-friendly shorthand. You are seeing the visual wrapper that makes an underlying string of on and off F electrical switches manageable for our brains.
That's exactly it.
Well, today we've unpacked how computers count using those fundamental 8-bit systems and why hexadecimal had to step in as the ultimate visual shortcut for designers. So whenever you encounter those random letters in your digital settings, you'll know exactly what's happening behind the screen.
Which is pretty cool to think about.
It really is. But it does leave us with a fascinating challenge on the horizon.
Oh, what's that?
Yeah, our digital infrastructure is expanding exponentially. And the source mentions that newer IPv6 network addresses now use 128-bit codes.
That is massive.
Right. If managing a 16-bit binary string was already an unreadable headache that forced us to invent hexadecimal, just imagine the sheer visual scale of 128 zeros and ones.
That sounds like an absolute nightmare.
Totally. So as our networks grow infinitely more complex, you really have to wonder, will even our clever hexadecimal shortcut eventually become too long for the human mind to comfortably read?